Hello everybody! This is a short little kind of recording that I decided to do just to give you guys an overall introduction to the carbon cycle and really carbon in general. So I'm not going to do too much in the intro or in the beginning of the video here just because I want to get started. Except for my thing isn't working. Here we go. Okay, so first of all, what is carbon? Carbon is the fourth most abundant element in the universe. It is found pretty much everywhere in all the spheres. It changes between forms. It does many different things, and as well as that, is definitely the building blocks of life. From fossil fuels to DNA, you'll find carbon. This kind of makes a little bit of sense, I guess, when I think about it, at least. Where do fossil fuels come from? Well, they come from dead animals, dead dinosaurs, things that have already died. So it's definitely in our DNA. And then after we pass away, it transitions then into something that we can use as fossil fuels. So, fortunately, putting it a lot more in the atmosphere than should actually be here at this time. But we'll get into that here. You guys should have some exposure to that through other classes, though. Okay, so two categories of carbon that we have are going to be inorganic, which means it's not associated with a compound formed by an organism. So things like, carbon dioxide, methane, things like that. Those are going to be things that are not, formed by an organism. But organic is going to be something that is actually formed by an organism, if I can say that. Things like sugar, DNA, proteins, these all have carbon in them. They're definitely organic. They're formed by organisms. So we'll kind of go into this a little bit more, but I'm just kind of giving you guys like a brief overview of the types of things we'll be going over. Kind of get everybody on the same page here. So initial carbon was present during Earth's formation. It doesn't increase or decrease globally. I think this is like kind of an important point here. Carbon is going to move through different spheres, different reservoirs. It's going to be, transitioning, not transitioning, but kind of like, maybe adding with something else like oxygen to, form CO2, break down into its simplest forms and go back to carbon again. And also the other thing that's very important to understand is the time scale piece of it. I'm going to record actually a different lecture today, kind of going over a little bit more about the time scales. But it is moving between different reservoirs on different time scales. So that is also a kind of an important thing to know. It is going to be in the ocean, in the deep ocean, stored down there at a completely different time scale than it's going to be in our atmosphere. Or even in the rocks, so we'll find them in sediments and seashells and shells of the little critters in the ocean. So that's the thing about carbon, is that it moves around, and it moves around in different time scales, and it pretty much affects or is involved in many different things that we use or, obviously breathe, things like that, and then exhale. Okay, so there's a complex series of interactions. I kind of went through this, through which carbon passes through the Earth's atmosphere, its land, its ocean, the cryosphere, the biosphere. It's really important to understand that when we're studying carbon, it's not just the atmosphere. There's atmospheric scientists that actually study it, biologists study it, chemists study it, oceanographers study it. Many different types of scientists actually study carbon and carbon cycling and the carbon, climate change. So it definitely is an interdisciplinary type of idea, and it definitely affects all of Earth systems. So it's more of an Earth systems type of science. So in this class, you guys will probably be exposed to other things that are about like far beyond atmosphere and more into things that are more chemistry or biology type of what do I say, related items there. I don't know. Anyway, so like I said, is exchanged in all of our systems at all time scales. So we have long-term cycling, which is going to look like hundreds to millions of years. And then we're also going to have short-term cycling, which are going to be from things like seconds, like when we breathe, also photosynthesis, things like, like that, also to a few years. We'll go over the timescale thing here. I'll do that in another video, so I don't want to make this one too long. Okay, and the business with the carbon reservoirs. You can really think about a reservoir as a place where carbon is stored. So carbon can be stored in our atmosphere through like carbon dioxide and methane, things like that. But it also can be stored in living biota. So like in plants and animals, that's going to be organic carbon. Like I said, seashells have a lot of carbon in them. Also, obviously plants are going to take in CO2. So, photosynthesis and the normal cycle of a plant's life, it definitely, it's carbon, involves carbon. And then soils, like I said, like when they die, these plants and animals die, then that carbon is going to go down into the soil. Due to sedimentary rocks, you'll find them in limestone. When new rock comes up and is exposed to the elements, then that definitely, there's more carbon available in that. And then, like I mentioned already, there's dissolved inorganic carbon through things like carbon dioxide, but there's also going to be dissolved in particular organic carbon, which are things like the seashells, and then organic and inorganic carbon in ocean sediments, which are like little pieces of seashells or, like different pieces of maybe sedimentary rock that makes its way down into the deep ocean. I can tell you that it's down there for quite a long time. That's definitely on a larger time scale. So, but all these things are working all together on our planet, and it's really fascinating to me, at least, how all of it works together. And you kind of have to have this like knowledge of the whole thing to really understand carbon cycling, and also I think climate change, to its fullest. Let's see. That's pretty much everything I wanted to say in this video. So I will see you guys again, hopefully when you watch the next one.